Dear viewers, welcome to another video in the series of Minitab tutorials. As part of this series, we have seen many videos on how to perform different graphical representations or statistical analysis in Minitab statistical application. But today's video is slightly different. Data visualization is the heart of statistical analysis. But have you ever wondered when should I use a box plot or a histogram or a control chart? All these three graphical representations are designed to study the variation in the data, but each serves a unique purpose. In this video, we will break down what they are, how they differ from each other, and when to use each one of this with different examples. So please stay tuned till the end of this video for a quick comparison summary of all these three graphical representation so that you can remember them forever. Let's get into the video. As I was explaining in the introduction, a histogram, a box plot, and a control chart is designed to study the variation in the data. All these three graphical representations are designed to study the variation in the data, but each one of that have a different purpose, a unique purpose, and something possible in one of these graphical representation is not possible in the other. So knowing which one to be used when is very important as a statistical analyst or as a Lean Six Sigma practitioner or as a TQM practitioner. So from that perspective, in this video, let's first understand each one of this. We have already posted a separate video explaining about histogram, box plot, and control chart. I will give you the link of all those videos in the description, which is a step-by-step explanation of these graphical tools. However, in today's video, we are going to see a comparison. So let's quickly understand what a histogram is all about. So as I told, the detailed explanation video is there in the description, but this is a quick understanding of what is a histogram. So for us to understand this, I have a sample data available with me. So this is pH value of detergent in a detergent manufacturing process. So let's quickly construct a histogram for this. So I click on graph, I click on histogram. As this is a continuous data, I would like to draw the histogram with the continuous distribution fitted line to see whether the data fits into continuous distribution, which is normal distribution. So I select pH value and then I say OK. What I get a histogram. So the histogram is what we get. So what does a histogram generally explains us? A histogram displays the frequency distribution of continuous data. It shows how often values fall into different intervals or bins. And what do we mean by bin? For example, if I keep my mouse pointer here, this is one bin, and this bin starts from 5.55 to 5.65, and in this bin you have two data points falling in this particular bin, or what we call it as frequency distribution interval, right? So this pH value, two data points falls in a range between 5.55 to 5.65. Only one data point falls between 5.65 to 5.75. Similarly, your overall data here, the total number of data points that you have taken is 25. So the overall data is divided into different bins, and how many data points are falling into each of this bin is counted, and based on this, the graph is represented. So this is what we call as histogram. So this histogram helps us quickly see the shape of the data. So one important purpose of histogram is it gives you the shape of the data. It helps you to understand whether the data fits into a normal distribution. It also helps you to understand whether the data is skewed. So what is skewness? I have explained in a separate video, but here skewness is how each side your tail is getting represented. Are you having tails with equidistance from the center, or one of the tail is more extended? So all this can be understood. The data fits into normal distribution, data follows skewness. Does the data have multiple peaks? For example, here you have two different peaks here for the given data. So all this could be understood with the help of a histogram. So histogram is an excellent way of understanding the distribution, the pattern of your process data. But some of the shortcomings of histogram is it does not give you a good comparison of multiple data sets in the single window. So it will be very difficult for you to compare multiple data sets if the number of data sets goes beyond 2 or 3 data sets. So to give you an example here, let me click on graph let me click on histogram and let me select multiple graphs in the same scale. Let me take a different pH value from supplier 1 and from supplier 5, and then I say OK. Here you will be able to understand very clearly the blue color histogram is narrow and the red color histogram is much wider. So as long as there are only two data points, it becomes easy for us to compare multiple data sets in histogram. However, if we have more than two data points, for example, I press Control E. Control E is the shortcut key to take you to the previous screen in Minitab. So here I select all my 5 pH values from 5 different suppliers, and then I try to draw a histogram. The histogram will look very cluttered. It's very difficult to compare the remaining 4. Supplier 1 stands out to be the best supplier when it comes to amount of variation in pH value. However, the remaining suppliers, it's very difficult to compare their data. So these are some of the shortcomings of histogram. You will not be able to compare multiple data sets. The benefit of histogram is it gives you the shape of the data. It helps you to identify the distribution of the data. So this is about histogram. Now from histogram, let's move to box plot. So box plot, also known as box and whiskers plot. So it is a compact summary of the distribution focusing on spread and central tendency, right? So rather than frequency count the number of data point in each bin. Here we don't get the frequency, instead we basically understand the spread from its central tendency point of view. What does it mean? Let us first construct a box plot for the same data. So I click on I click on graph, I click on box plot, and here I select box plot for one variable, right? So I click OK and I select the same pH value. Now I click OK. So what I get a box plot like this. So this is the pH value box plot. pH value _1. Just a minute. Okay, so maybe we will draw it for the original pH value, not pH value _1. So we will draw it for pH value, the 25 data points, the example with which we started. So if you see this box plot gives you a clear idea of where is your median. It also gives you a clear idea of where is your Q1, which is also called as your quartile 1, Q3, which is also called your quartile 3. Where is the minimum value for this data? Where is the maximum value for this data? Does this data contains an outlier? Yes, it has a star. Below the star, the immediate first data point will be called your whiskers. So a box plot gives you a complete understanding of your data from its central tendency, how far the data is spread, where is your outlier, where is your min, where is your max, where is your Q1, Q3. So it gives you a complete picture. And here we have taken the same data as an example, so it gives you where is its central tendency. So box plots are especially useful when you need to compare multiple groups. Just now we saw how it is difficult to compare multiple groups using a histogram. Box plot gives you a clear comparison if you want to compare multiple groups. What do we mean by that? Let's go back and click on graph, go to box plot and select box plot for Y1, Y2. Now I select my pH value from supplier 1 to supplier 5, and then I draw a box plot. What is very difficult in a histogram where you need to compare multiple graphs becomes easy in a box plot, where you are able to compare all the 5 suppliers and decide supplier 1 is doing a good job. Maybe relatively supplier 3 and 4 is doing relatively better job compared to supplier 2 and 5 with the amount of variation in them. So this is the benefit of using a box plot. However, the shortcomings of a box plot is they don't reveal the exact distribution of the data like how a histogram does. And similarly, both histogram as well as your box plot cannot give you a trend of your data. They don't give you the trend because it's not a time series graph. Whereas a control chart will help us to do that, which we will see as our next graphical representation. Also, a box plot cannot give you whether your data have skewed or your data have bimodal, 2 peaks. These are things that a box plot cannot represent. Now we will move to the third graphical representation, which is control chart. Control chart is a powerful tool used in quality management and process control. Unlike histogram or box plot, control chart focuses on variation with respect to time, variation over a period of time. Each data point on a control chart represents a measurement at a specific time period or at a specific batch collected with respect to a time period. So what do we mean by that? Let's first draw control chart for the same pH value data, and this pH value data is collected chronologically. What is chronologically? This first data point is collected on day 1, this is day 2, this is day 3. So this is a chronological data. That is a prerequisite for you to draw a control chart. Similarly, knowing the distribution is also a prerequisite for you to draw the control chart. Here I already know that my data is normally distributed. If you have any doubt, you can click on stats, basic stats, and you can go to normality test, and you can see whether Anderson-Darling is selected, and you can select pH value and click OK. You will get your Anderson-Darling test for your data. If your p value is greater than 0.05, you can decide that your data is normally distributed. Here it is 0.17, so my data is normally distributed. So it's fine for me to go ahead and draw a control chart. So I click on stats, I go to control charts for variable data, and here I'm going to choose IMR. So friends, we have made a detailed video on what is control charts, what are the different types of control chart, when to use which control chart. So I'll give you the link in the description. You can look into those videos for a detailed understanding of control chart. But here we are quickly getting into the control chart. I draw an IMR chart for the same pH value, and then I click OK. So here I get the control chart for my pH data. And here if you see the control chart is drawn with respect to time. So your x-axis is always the observation with respect to time, first day, second day, third day. So instead of that, you can also bring in date, right? And how your data is performing. As a result, you can see there is an increasing trend, and then there is a reducing trend. So this trend can be established when you are trying to do a control chart. Also, a control chart can help you to identify whether there is any outlier, because if the data point goes outside your upper and lower control limits, then you will have your data going outside that will be represented as an outlier. So if a point is going beyond the limits, then it is understood as a special cause, or can also be called as an outlier. So an histogram or a box plot summarize the past data. A control chart helps us to give you the variability in your data as in when it happens. So it's a real-time graph. You can create a control chart and start feeding data as in when the data get collected. You will be able to get a real-time understanding of the amount of variability in your data. So this is what you can do in a control chart. Can I compare multiple data sets using a control chart? There is a way to do it. Let me explain you. So here I had supplier 1, supplier 2, supplier 3, supplier 4 and supplier 5 data, but I have compiled it in a different way where the individual values, the pH values are taken in column 10 and the supplier name is taken in column 1. So here I will have supplier 1, and after some time I will have supplier 2, after some time I will have supplier 3. So the same data is being compiled in a different way. Now I click on stats, I go to control charts, and I click on control charts for individuals, and here I select all my 5 pH values, and then I click OK. Sorry, first apologies, I need to remove this. Select, I click OK. Apologies friends, I have done it wrongly, sorry. Control E. I need to take pH value as my graph variable. I need to go to IMR options and go to stages, and here I need to take supplier name in stages. And now if I click OK, and then if I click OK, I will get the comparison of all 5 control charts in a single window, and you can see the center line is almost same for all. However, the control limits is very narrow for your supplier 1, whereas it is very wider for your supplier 2. For supplier 5 also it is relatively narrow. So this is how you can compare different data sets in a control chart. But box plot is a much better way of comparing all these different data sets, and you want to compare their variability. Box plot is a much better graph, right? So now let's quickly summarize. I hope the explanation is clear. Now let's quickly create a summary slide for all these three. So to create a summary slide, we will now go back to our PowerPoint presentation. So here I have histogram, box plot, and I have the control chart. So from a usage perspective, histogram is used to understand the distribution and the shape of the data. Box plot is generally used to compare the spread and median of multiple data sets, whereas a control chart is used to monitor the process stability over a period of time. That is the first primary usage. The data type that we use for a histogram here is continuous data, and for a box plot also we use continuous data, and for a control chart we use continuous data, but continuous data collected with respect to time. It should be a time series continuous data. It should be collected in a chronological order. Okay. As I told in the beginning, does a histogram show the shape of the data? Yes. Does a box plot show the shape of the data? No. Box plot does not give you the shape of the data. Whereas a control chart also does not give you the shape of the data. If you are more interested about understanding the shape of the data, understanding the distribution of the data, then it is better to go with histogram. Box plot and the control chart does not solve that purpose. Does a histogram gives you an understanding of whether your data have outlier? Yes, but not in a very clear way. You should be able to see, okay, there is one bar very far away from the central tendency. It could be an outlier. So you have to identify it like this. Whereas a box plot gives you an understanding of your outlier, yes, very, very clearly. So you can simply understand a box plot with a star means there is an outlier, and a box plot which does not have a star means there is no outlier. So a box plot gives you a very clear understanding of whether your data have outlier or not. Does a control chart gives you an idea of outlier? Yes, it gives you an idea of outlier by understanding if there is a data point beyond your control limit. Yes, there is a presence of outlier. That is how you need to understand presence of outlier in all these three graphs. Histogram gives it in a very visual way, not in a very clear way. Box plot gives you in a clear way by putting a star, and the method used here is called interquartile range method, IQR method. So we have posted a detailed video on how outliers are identified using an IQR method. I will share you the link of that video in the description. You can go through that. And in a control chart, an outlier is understood using the data point outside your control limits. Does histogram and box plot show you the trend of your data? The answer is no. They don't show you the trend of the data. Does a control chart show you the trend of the data? Yes, they definitely show you the trend of the data, because because it is a time series data collected in a chronological order and also displayed in a chronological order. So the best use of a histogram is to explore the shape of the data. The best use of a box plot is to compare the variability of multiple groups of data, and the best use of control chart is to detecting special causes in a process and understand the stability of the process. So if I want to summarize, use histogram to study the shape of the data, use box plot to compare the spread across multiple groups of the data, and use control chart to track process stability over a period of time. So next time, if you want to analyze process data, especially the variability in your process data, you can ask yourself three questions. Am I exploring the distribution of the data? Answer, histogram. Am I comparing multiple groups of data and their variability? Answer, box plot. Am I monitoring my data over a period of time to understand the trend and the stability of the data? Answer, control chart. So these three answers will help you to understand which chart or which graphical representation is best suited in the given scenario to analyze the variability of your data. Friends, I hope this video was useful. If you find this explanation useful, don't forget to like, share and subscribe to our channel, so that you will be able to find more videos on statistical concepts, Lean Six Sigma concepts, TQM concepts, and Minitab tools and techniques, tutorials on Minitab tools and techniques, and quality related videos. Thanks for your time. Thanks for your patience. As I told, some of the related videos to this particular content, I will share you the link of those videos in our description. You can get into those videos also to get detailed understanding of some of the topics which I used during this video. Thank you. See you again in another video.